Good afternoon, everyone. This is Matt Kinsman, Head of Content at SIIA's Connectiv division. Thanks again for joining us today for Blockchain and Digital Currency. What is it and how will it impact information companies? At this time last year, digital currency, particularly the daily ups and downs of Bitcoin, were all the rage, while conversations around blockchain were just starting to become widespread. Today, it's hard to go a single day without seeing headlines about how blockchain will completely transform a particular industry. I think it's a safe bet that the majority of our attendees here today have at least a basic understanding of what blockchain is and how it works. And our webinar today is focused on offering a deeper understanding of both blockchain and digital currency and what they will mean for information providers. Our speaker today is Scott Greenwell, founding partner and COO of Unleashed Technologies, which offers an extensive array of digital services from digital strategy and web development to e-commerce and cloud hosting. As a reminder, you can submit questions via the chat tab in the lower corner of your screen at any time during this presentation, and we will hold a Q&A at the end. With that, Scott, please take it away.
Thank you so much, Matt, and thank you all for joining me today as we walk through. I'd like to start out by inviting you to take my quick one-question survey. If you could just go to that ETC link down here at the bottom left of your screen. It should be a very quick entry. That being said, Matt has already introduced me, but my name is Scott Greenwell, and I'm the Chief Operations Officer of Unleashed Technology. And we have been in business for a little over 11 years and focused in open source and new technology trends from the very beginning. My history itself started in the gaming industry and has moved into web technology and VR and additional technologies such as blockchain. Now, a little bit about Unleashed Technologies. We're a website design, development, and hosting company, and we focus primarily on open source technologies such as Drupal, WordPress, Magento, and Symfony. But we're always looking towards the future and seeing what holds for not only web technologies, but technology in general. And we've done interactions in virtual reality, PWAs or progressive web apps, AI and voice assistant technology, as well as blockchain. Now, it looks like we had a few, looks like there is some sort of technical issue, unfortunately, that's going on with the survey. But really what I wanted to ask is, what does the audience here think blockchain is actually used for? Normally when we see this, there's a large amount of financial transactions, store of value, cloud storage, and things like that. But really everything on this list is something that is currently being used, or blockchain is currently being used to fulfill, including breeding digital cats and robots. I know that sounds odd, but it's true, and we'll cover that here in a bit. So what will we be covering? An overview of what blockchain technology is, why you would use blockchain and how can it be applied to information providers particularly, and then what we're looking to see in the future with blockchain and digital currencies. So what we won't be covering. This is not a cryptocurrency investment strategy or a blockchain investment strategy talk. We won't be covering which blockchain or cryptocurrency is best, as they all have different uses and applications. We also won't be covering how to build blockchain applications or how to mine cryptocurrency. There are a number of links at the end of this presentation. If these interest you, I would encourage you to look through the documentation and the links that we provide there. So what exactly is blockchain? Blockchain is a shared distributed ledger that facilitates the process of recording transactions and tracking assets in a business network. It's comprised of unchangeable, digitally recorded data in packages called blocks. Each block is then chained to the next block using a cryptographic signature. This allows blockchains to be used much like a ledger, which can be shared and accessed by anyone with the appropriate permissions. This function of chaining these blocks together is where blockchain derives its name. In its simplest form, it's really just a new way of sorting and sharing information. The two most important points in this definition are the distributed ledger and the block's cryptographic signature. It is in these two details that really define the power and the adaptability of blockchain. Now, One of the best ways that I've heard describing what blockchain is actually a history lesson put on by the Westpac Group. Now, the story here starts back in about 500 AD with the Yapese tribe on the island of Yap. Today, this island is what we would know as one of the islands of Micronesia. The Yapese had a currency made of stone quartz called a rye stone. Now, this is a rye stone. Rye stones were generally very large circular discs with a hole in the middle, and the stones varied widely in size. Some could be larger than 3 meters in diameter, half a meter thick, and they could weigh as much as 4 metric tons. So spending these like traditional coins was a bit difficult because of their size and their weight. But the Yapese people solved this by never actually moving the coins. Instead, coins were placed in prominent locations around the island, and every Yapese knew who the owner of the coin was by memory. Now, if somebody wanted to transact these coins, they would then announce it to everyone on the island, and then that would update their knowledge of who owned which stones. With this announcement, the coin was exchanged. Now, the Yapese were using what we would call today as a distributed ledger. It was a ledger as each of these Yapese tribesmen had a recollection of who owned what coin, and it was distributed because it wasn't just known by one person, but by all. Now, the Yapese could have asked one person to keep track of this mental ledger, and then that person would have needed to be extremely trustworthy, both in terms of honesty and in administrative skill. The monopoly that person would have had could have led them to charge a fee, impose transaction limits, or impose times at which transactions could be made. The problem could also arise if that person left, fell ill, or if their integrity was compromised in some way, making that system extremely vulnerable. Well, in today's standards, we would call that centralized person a bank. Distributed ledgers provide many bank-like functions without requiring trust in that central entity. Now, in the Yapese example, a member of the tribe couldn't take ownership of a stone arbitrarily, because if there was a dispute, then the tribe would be able to state the correct owner by validating it with other members of the tribe based off their knowledge of the ledger. So fraudulent transactions weren't very likely. Also, if one person of the tribe is unavailable or moves away, thereby losing a copy of the ledger, transactions can still be validated by other members of the tribe, making the system fault resistant. Now, one of the most interesting parts is what happens if a coin gets destroyed or lost. In one example, a large storm came and a rye stone fell overboard during a voyage to the island from where it was being quarried. To the other Yapese tribesmen, this really wasn't an issue, as they could imagine that coin sitting at the bottom of the ocean. The tribe mentally added this to their ledger, just like any of the other coins they could see on the island, and continued to use it for transactions. So even if in all intents and purposes the coin didn't exist, it could still be used to transact. Now, as I mentioned before, distributed ledgers are only one of two key concepts for blockchain. The second is the use of cryptography, or more specifically, a cryptographic hash function. So to explain this concept, let me tell you how I can distill the Lord of the Rings into just 20 characters. So it turns out that every book has a unique, untraceable fingerprint. There are certain functions, by which I just mean mathematical equations, that computers use, where if you put in a book or a string of characters, you would get out the other end a unique 20 to 30-digit code. This code is unique to any given input, so when you put Lord of the Rings into this function, you would get this 20-digit code. If you were to put an exact copy of Lord of the Rings with one additional comma change, you would get an entirely different 20-digit code. These codes are so different that you would be unable to connect either code to one another or to the original version of Lord of the Rings. Now, functions that do this also have some pretty amazing uses. You can use them to validate information. Let's say you were about to sign a lease and you wanted to make sure that you're signing the same copy as your landlord. You could drop your version and the other person's version into this function, and if there was even a single comma difference, they would produce different 20-digit codes. If they both come out with the exact same code, you know that they are 100% the exact same document that both of you are signing. Now, you can also use functions like this to obscure your identity. You could combine your personal info, your name, date of birth, hair color into a single string of text and put that text into the function to generate a unique 20-digit code. You could then use this code as your internet identity to conduct business online, confident that no one could connect it back to you directly. But later, if someone wanted to verify that it was you who owns this code, you can show you're the only one that knows the combination of inputs that can regenerate that code. So now that we understand the two building blocks, let's tie them together a little bit. So going back to our YAPs example, we learned that distributed ledgers allow for transactions to occur even when a coin doesn't exist, just like at the coin at the bottom of the ocean. And we also saw that it's nearly impossible to steal coins, and this is because each YAPs knows who owns a given coin and whether any transactions have changed that ownership. Now, imagine that these ledgers, instead of being stored in these people's heads, are actually stored on computers around the world, managed by incentivized volunteers. So it would still work just like the island. Each computer would have a copy of the ledger showing coin ownership that's visible and known to everyone. And every time a person wants to make a transaction, they would just announce to the computer network that they wanted to send coins to someone else. All other computers, upon hearing that announcement, would update their internal ledger by deducting a coin from the sender and adding it to the recipient. We would only be missing two things to make this example viable in the real world. The first thing we're missing is a way of disguising the identities on the people of the public ledger, as most of us probably wouldn't want to put our names and transaction history in public view. We can solve this with our hash function. Each person's identity and details can be reduced to an encrypted 20-digit code where only the owner knows that input to generate that code, thus anonymizing the participants. The second thing we need to make this workable is a way to quickly compare ledgers between computers to make sure that they're starting from the same version of the transaction history, as we can't send the entire transaction history across the network. The bandwidth would be too great. So instead, this can be solved again with a hash function. Each computer can turn its copy of the ledger into a 20-digit code and compare it to the codes produced by all other computers on the network. If the codes are the same, it's likely that they represent an accurate view of coin ownership. Implicitly, this makes it almost impossible to tamper with the ledger, because to do so, a person would need to tamper with thousands of different copies of the ledger stored independently on thousands of computers around the world, all at the same time. Oh, my apologies, I hit the wrong button. So in this example, we've actually just created Bitcoin. It's a shared distributed ledger that is secured through cryptographic functions to create invisible coins that we can use to transact. Anyone can join this network by creating their own 20-digit coded identity and obtaining coins from another user on the network. So I know that was a rather long-winded explanation, but why would I use blockchain over a regular database system? Really, the biggest benefit is to remove the trust out of an authority. So in this case, a trusted entity like a bank or a middleman partner that would validate and allow for trust from one party to another. So if you're looking to share information and data entries across organizations so that they're all on the same page, if information needs to be publicly auditable but still remain anonymized, if you're trying to decentralize control of this data or of protocols within a system, and we know that we can also make them immutable assets with a trustless authority, thereby acting as an escrow agent. Now, there are two types of blockchains. You have your public blockchains, which are similar to your Bitcoins or Ethereums, and those are available for anybody to access, read, and write to. And you also have private or closed blockchains. These are generally permissioned, so you have to be given access to the blockchain to be able to make transactions or to even read or write from that database. There are advantages to being in the open side. Those would be that we have native assets. We can then do proof of work or proof of state security, and anybody can access these networks. The downside is because there is a lot more players involved, the speed of transactions could be slower. They're generally more expensive in something that we call gas, or the cost to operate a particular transaction. And they're generally going to be a little bit less focused on a particular use because they're trying to be more open to the general public. Generally, these open ledgers are there to verify transaction histories, whether that be through smart contracts, which we'll get to here shortly, or if it's just a transaction of value. Now, private blockchains are generally going to be used for industry conglomerates or large organizations or associations that are looking to share data and share ownership between those companies. They're generally much faster because they have a smaller amount of participants. They are a little bit more secure because every participant that joins this network has been pre-approved or been given access, and they're not anonymized. Because they were given access, every identity on the network is a known identity. And this is great for auditing and verification purposes, whether that means we're just trying to store data, think more in the healthcare industry and we want to validate that that data is correct, or if we're trying to share governance, maybe a voting structure, or we're trying to make a decision and every party has an equal power within that decision-making structure. So how can this actually be applied directly to information providers? What are some of the examples of what people are using this for? Right now today, there is a large swath of different blockchain technologies and digital currency technologies that are driving industries forward. While blockchain and digital currencies have been around for a number of years, due to the volume of news and article information and public interest, they're really starting to make leaps and strides forward. Some of those examples would be in payment and money transfers, smart contracts, digital identity, supply chain communications, and even gift cards and loyalty programs to make sure that all of this is auditable and valid. So I want to walk through a couple of these examples with you and showcase some of the technologies that are out there. So starting with payment and money transfers, this is where 90% of the people that I talk to, their mind goes to when I mention blockchain or I mention any digital currency. These three technologies, Bitcoin, Ripple, and Dash, while they are all meant to transfer a store of value, they are all trying to solve the same goal by removing the middleman that allows transactions to happen. So credit card companies or international payments where it may be going through 3 or 4 different entities to validate that that store of value has been transferred to the new bank or the new entity. All the advantages of using these through blockchain is that all transactions are provided on the same ledger. So in the case of Ripple, which is meant to be peer-to-peer transfers from banking entities, every bank is then on the same ledger. So it removes the ability for the double spend problem, which is if I have $20 and I promise I'm going to give $20 to Jim, but before I actually hand it to Jim, I hand it to Sally. So now I've technically spent that $20 twice. It's impossible to happen on a singular ledger because once that initial transaction to Sally happens, it has already been transferred and I no longer have that $20. Now, it's trustless in the fact that there is not a singular entity that owns the information of this system. It's owned by every participant on the network. So there is no trust in a middle party. We're doing a direct trust via the network. Now, Bitcoin, Ripple, and Dash are some of the more common areas that we see out there. One of the next areas that I want to highlight, and one of the more innovative sections of blockchain, is something called smart contracts. A smart contract is really just computer code, and it's a digital contract that's based on the blockchain and stored within it. It's a self-executing agreement that converts transaction deals into this computer code. The data being stored on the blockchain means that once the contract is written, it is no longer changeable. So much like if I went to a notary and said, both of us have signed this agreement at this time, that is then legally binding, and I am unable to change it without going back to the notary. The smart contract acts very similarly to this. Not only do they act as legal agreements, they can also act as autonomous processes. So as you see here, we have a couple of examples that are underneath of Ethereum. I have Storage, Arcade City, Golem, and CryptoKitties. The first one I want to highlight is Arcade City. And the reason I want to do that is it's a smart contract that is trying to replace an entire company's operations with one digital contract. So Arcade City is trying to replace Uber and be the middleman, essentially, or the middle processing unit between an individual driver and the person that wants to pay for a ride. Now, in Uber's model, there are hundreds of people that are processing these transactions, validating the transactions, and then splitting the money between Uber and the end driver. In Arcade City's case, this is all being done automatically, and verifications have been put in place through the smart contract to ensure that the rider has gotten from point A to point B, that there were no any sort of ancillary problems or issues, the car didn't break down, and automatically transfers this payment. So another example that we have here is Golem. And Golem is a smart contract aimed at decentralizing computer processing power. So instead of processing tokens for a store of value, I'm processing tokens that represent a amount of processing power. So right now, a good example of something like that would be animation companies. Or those that are trying to do automated learning and need heavy amounts of processing power to analyze that data or render that information. Golem essentially takes that and spreads it out into bite-sized pieces across the entire network to then generate that processing power. Storage is similar in the fact that instead of processing power, it's storage. So I can actually rent out or decentralize files and documents across multiple different users across the storage network, and all of them serve then back to me, the end user. But my data and my actual transaction policies are all hidden and anonymous throughout the network. So it's essentially a decentralized version of Amazon's web services. Now, CryptoKitties is an interesting smart contract, and it's more in the games arena. But I always thought of this as a very interesting example where they're trying to take the idea of Pokemon and put it into an online web application. And each quote-unquote Pokemon has a store of value or is valued based off of its random attributes. All of these are generated by the contract, and then owners of these CryptoKitties can then sell or trade them amongst one another. And if I were to own a CryptoKitty, I would own this in its entirety, and that ownership is stored in the blockchain. Now, while this is a very random example, other ways that this could be processed is for art and licensing fees, ownership of media, and even ownership of ownership of the authority of that media. So right now there is a very big problem in the entertainment industry with Michael Jackson's ownership and the ownership of multitudes of his songs. There is a problem right now where 110% of the ownership is owned. So there's 10% that people think they own that they really don't, and because it was done prior to any sort of major technologies, really rooting out who owns what has become a major problem. If this were started on blockchain, from the beginning, we could trace back its ownership from its inception through all of the permutations and all of the transactions of that ownership. Now, another good example of utilizing smart contracts is the idea of governance and proxy voting. So projects like Democracy Earth, they're looking to create an entire global voting structure allowing everyone in the community to vote on social issues, from environmental protection to the way that we want to internationalize, or their feelings on Brexit. While companies like AST and IBM are looking to build proxy voting structures which will allow for real-time, immutable proxy voting structures for both companies and government entities. So by doing this and by giving every person an anonymized identity, we can validate that they are in fact a real person and not somebody that shouldn't be voting, but we can also assure that they are only able to vote once and not in multiple areas. Now, digital identity is another very good example of blockchain. As we saw in some of our earlier examples, we can use blockchain to anonymize identities in the application itself. We can also use this to create IDs, online account logins, e-residency, passports, and birth certificates. Current methods use problematic password-based systems, and they're generally sharing of secrets, such as a forgotten password link, and then you have to put in your grandmother's maiden name. And these can be extremely insecure, especially if they know information about you. Blockchain-based authentication systems are based off of that irrefutable identity verification. Again, that 20 to 30-digit code that we created in the beginning. And this can be created out of anything that we know of, whether it be information about us or things that we enjoy or like. Using this digital signature based off of that public key, we can then use this for validating the number of participants or the identity of those participants. Some of the most exciting examples of this are actually in the nonprofit association space. One of them that I have here is the United Nations World Food Program. In middle of 2017, had sent 10,000 Syrian refugees both digital identities and funds to pay for food and medical supplies after fleeing Jordan in June of last year. They were able to do so even while some of these refugees remained behind enemy lines. In any other traditional payment method, this would be impossible because you would have to physically meet with or physically interact with those people. In this case, they were able to do everything digitally and verify that they are the correct participant and not somebody that shouldn't have been getting relief, but actual Syrian refugees. BitHub Africa is aiming to supply remote villagers and Africans access to banking and credit cards. With the dispersed population in remote regions of Africa, it's really hard to give every citizen access to services we take for granted every day, such as being able to go to a local bank and validate my identity with the bank itself and using that for government-related identification. By doing a blockchain-based set, we can now give anyone in Africa a way of interacting with most government entities and other people outside of Africa in a normal 21st century model. Other organizations are looking to build services to prevent against identity theft or storing your private or secured credit history for loans and other credit services like ShowCard and Bloom. These personal identification programs are looking to change forms of credit monitoring and allow for more granular control of your credit applications, as well as the ability to see all of your positive and negative actions in one location. So right now we go to 2 or 3 different providers to try and get our credit score, and we try and marry the information between all 3 of them. In a blockchain set, we would be able to do all of that automatically, and you would be able to see everything live as it happens. So no waiting 30 to 60 days or only being able to check your credit history once or twice a year. One of our other good examples of this is supply chain communications. And we have a couple of different examples here. Most of the things that we buy aren't really made in a singular location, but instead by a chain of suppliers who sell components. So as an example, we have graphite for pencils. The company that receives these materials then assembles them and markets the final product. The problem with this is that if any one of these components fails, the end step company takes the brunt of the backlash. But by utilizing blockchain technology, a company could proactively provide digitally permanent and auditable records that show stakeholders the state of the product at each value-added step. So in this case, if there was little graphite coming out of the mine, we could show that to stakeholders immediately and show the downstream impact of what that would have. The Soil Association and the International Pole and Mine Foundation here are looking to provide food tracking from farms or fisheries all the way to the end customer. So should a defect be found and a recall is necessary, it can be followed all the way back to its point of inception and see all of the products individually that were affected by this defect. It makes it much easier to track which inventory needs to be recalled, and instead of saying every piece of food that is associated to this shipment request, we can literally go down to each line item and say this particular food item or this can went through the processor that was either had some sort of contaminant on it, and I don't have to get rid of the entire created load of the warehouse at that time. I can only target a small subset of things that were processed through that one bad canner. The Blockchain Trucking Alliance, however, is also looking to do this for trucking transactions. Much like our supply chains, if I'm trying to ship something from California to Maryland, you're going to have 7 to 10 people that handle that package. Right now, unless everything is going through an Amazon or a FedEx or one of the major carriers, you're unable to see some of the steps. So as an example, if I order something from China, I'm not able to track that package until it reaches here in the US under FedEx label. In a blockchain set, every single shipper or person in that shipping step would have their own wallet ID or their own identification ID. And instead of coins on that blockchain representing a state of value, each coin represents one package. And I can then transfer that coin from person to person. Now, while that seems a little abstracted, the point of that is that we can validate that I have correctly transitioned from one identified person to the next identified person, and I can see that transaction history live at any given point in the process. So if a package were to go missing or if it were to be damaged, we could see exactly when that package was damaged, by which carrier, or who was the last person who had ownership of that package. Now, one of the last examples that I have for you is document management and proof of provenance. Similarly to our smart contracts, we can utilize blockchain to store copies of documents, but we can also use the blockchain to track each revision along the way and who it's associated with. If there were a particular user that then submitted a new revision, we have the time it was, what has been changed, and who is the one that did it. This allows for some users to see information, if this was on a public blockchain or in a private blockchain, the view could be controlled either publicly, so everybody has access to view it, or in a private blockchain, you can set this up so only certain people have access. So in the idea of governance documents or board of director meeting notes, you can make those only accessible to particular IDs on a private network. This allows users to see the authorized information and push revision information to be voted on publicly prior to being stored and associated as a finalized version. Technologies like this are really going to put notaries and patent offices out of business, in my opinion, in the next 5 to 10 years, once that we can get this into a global utilization. Now, record keepers, MyDocSafe, both of them are really aimed at storing documents, important documents and immutable documents. This is really important when it comes to the healthcare and the pharmaceutical industries that need to have that chain of custody and the idea that this document has been written and it will never change, and we can validate that. Factum, however, is more on the notary side of things, approving documentation, purchasing of housing or land. And all of these things are currently being utilized on a breakoff of the Ethereum blockchain. There are hundreds and hundreds of these types of projects currently going on. So much like in the early days of the internet, we had hundreds and hundreds of different search engine providers, Google, Yahoo, Lycos, Bing, and Ask Jeeves. And realistically, we are down to one or two of those. So while we continue to progress, we're going to see more things pop up, and hopefully we eventually see those that start taking these particular areas and becoming the Googles of those industries. So looking to the future, we just gave a few examples of what some companies are using for blockchain, but we really do expect to see countless companies enter the foray of blockchain in the next 2 to 5 years. One of the things that we would expect to see is a large number of blockchain initiatives will fail. We constantly akin this to the beginning of the internet era, and we're very much in the 90s in relation to blockchain technology currently. So hundreds and hundreds of different projects will spawn. We do expect a large portion of these fail, and as you've seen over the past few months, the decrease in value and the decrease in transactions that are happening are because we are seeing projects fail. I do not consider this a bad thing because it's level setting the expectations of the technology. We're going to start seeing more common uses outside of finance, such as the gaming industry, as we saw with CryptoKitties, or transactions of property and less of financial value. We also expect blockchain to meet the Internet of Things and artificial intelligence. If through smart contracts we have appropriate processes in place or valid protocols that these systems can use, we can then start using things such as Alexa or Google to then start processing entire transactions or entire processes utilizing nothing but voice, as well as being able to analyze all of this information that's being stored in the blockchain via an artificial intelligence. We also expect to start seeing smart contracts come into their own and developing completely autonomous companies like we saw with the car company that we had on our smart contract slide. I really do see this as being more and more common, and if you Google smart contract autonomous companies, you will find hundreds and hundreds of different projects that are currently active that are all trying to solve variably different things. And then lastly, we expect to see more state-sanctioned cryptocurrencies. While I don't expect the U.S. to adopt this anytime soon, the U.S. Treasury has already started to explore and investigate this. There are already a number of state-sanctioned cryptocurrencies out there. Venezuela, as an example, has their own coin that is state-backed, and they're trying to use that to get out of their financial crisis and provide something that has a more stable store of value. We also have the crypto ruble out of Russia and Dubai coin. Dubai was the very first to implement a state-sanctioned cryptocurrency, and you can use Dubai coin to pay your taxes and any sort of government fees in that area. In this sort of set, we would love to get your thoughts, any of your theories, and what you see coming in the future. And I would like to say thank you very much for being on our webinar today. And at this point, I'd like to open it up for any questions or comments that you may have.
Scott, thanks very much. Terrific presentation. Folks, we are opening it up for Q&A at this point. You can submit questions via the Q&A tab in the lower left-hand corner of your screen. Please type your question in. You can direct that to all, or you can direct that specifically to the speakers. But please start typing your questions in now. Scott, we do have a question in right now, and you gave us a nice variety of different examples. One thing with SIIA is SIIA represents a variety of different marketplaces, different verticals, and including the education segment. And the question is, will you be able to give an example of how blockchain is being used or could be used in an educational setting, whether that's for admin, teaching, or for learning purposes?
Absolutely. And I do apologize. It's another permutation of Democracy Earth. But in that same organization has another currency or blockchain out that's really aimed for more of the education purposes and being able to validate certifications. So that's one of the larger problems is being able to say that this person has been certified by an education or an organization. So utilizing blockchain to store those certifications against a particular identity is one good example. When it comes to teaching and additional learning, I have seen a couple of examples where they're trying to do class structures and quiz structures through blockchain as well. Again, this is more to validate and then to be able to provide that information back to the teacher, knowing that the end user has, for a test example, gotten a completely anonymized set of questions. All of this can then be tracked and immediately stored or scored without the teacher really having to collect or watch or validate.
All right, terrific. Folks, just a reminder, please enter your questions now. Scott, we have another question, and the question is, with the price action in Ether, do you think a large adoption of Cardano will occur, mostly for transaction speed purposes?
This is definitely a good question. I will state that I am a big backer of Ether. So that may bias my opinion a little bit. But for those that are unfamiliar with what those two are, Ethereum and Cardano are both smart contract vessels. So in this case, the big difference between the two right now is very much in transaction speeds or in the amount of load on the network. I do believe Cardano has an advantage at this point in time, and I do expect to see more adoption of Cardano, especially over the next few weeks. Where I see this becoming a complete unknown is if Ethereum is able to switch from a proof of work to a proof of stake model. That would be the one thing that would absolutely increase the transaction and the throughput of Ethereum and Ether in general. Whereas I know right now Cardano has got the edge. So without trying to say one is better than the other, it's really a wait and see, but I would start to lean with you, Don, that we're going to see more adoption of Cardano, especially with the issues that we've seen with Ethereum over the past month or two.
All right, excellent. And Don has a follow-up. Would Ether change from POW to POW?
Proof of work to proof of stake. Unfortunately, Don, I don't have an answer for you because I think that there is very much a big debate on how that would occur. And I don't want to put something out there that I don't know is 100% true. There are a number of links, and actually I'm going to skip to our next slide here so that some of you can take a look. There are a number of different blogs, learning resources, and different blockchain pages that may give you a little bit more. I would highly encourage you to go to ethereum.org and join the community there, only because they are constantly talking about this issue and other ways that they can take it from proof of work to proof of stake.
All right, very good. Scott, we have a new question. How might blockchain be presenting its use in the future to pension funds, endowments, or sovereign wealth funds? Have you seen much adoption?
So let me preface this with I am by no means a financial analyst or in the financial sector in that sort of set. So I'm going to try and attack this. In this case, pension funds, endowments and sovereignty, I would absolutely say yes. I don't know that they have been completely adopted, and I know that there are a number of organizations, even here in the U.S., that are trying to use them eventually for pension funds or to try and turn these sort of long-tail investment services into documented payout systems. One of the ones that I have seen is something similar to a company called Highrise, where they're essentially trying to do investments into large building and residential purchases. So instead of having to front $4 or $5 million to purchase a large building, that can then be segmented out into much smaller payments, and then blockchain is being used to account for any sort of the percentage yields or the monetary gains of that building asset, and then divide that amongst all the participating members.
All right, very good. Other questions at this point? Good. Well, Scott, I think you've given us some terrific information today. For our attendees, we will be distributing an archive of this webinar. I would like to thank Scott Greenwell of Unleashed Technologies, our speaker today. Terrific presentation. Thank you again for joining us this afternoon. This concludes the webinar.